operators and operands. So operands are the pieces of data on which the operator operates. Right? So first we'll understand the difference between the equal to sign, this operator, as it is used in a programming language in like Python, and as it is used in mathematics. It has two different meanings. So we'll talk about. So in Python, this operator is an assignment. This I've repeated again and again, because I find that people who are doing programming for the first time are unable to understand that when a is equal to 5, we are actually assigning the value of 5 to a, right? And for that assignment, the best way to think about it is like this: a reverse arrow 5. So we are assigning the 5 to a. Okay. Then we will talk about the various types of operators. We'll talk about the various types of operators used in Python. Let me clear the screen and come again. Various types of operators used in Python. So today I will be talking about that. The first is assignment operator. The second is arithmetic operator. First is assignment, second is arithmetic, third is comparison, fourth is logical, fifth is bitwise, and sixth is special operators. Let me repeat. So there are basically 6 types of operators in Python. First is assignment. Then we have arithmetic. Then we have comparison. Then we have logical. Then we have bitwise. And finally, we have special operators. So these are the 6 types of operators that I will be talking about today. And I will talk a little bit about order of precedence of operators. If an operand has 2 operators on its 2 sides, suppose it is 4 plus 5 into 6. So now this operand 5 has a plus on its left and a multiplication on the right. As you all know, the BODMAS rule, the bracket and off, division, multiplication, like that. So that applies here. Then we'll talk about the 6 comparison. So I said there are 6 types of operators. And out of these 6 operators, the first one is assignment. Now, assignment operator itself consists of 6 operators. These are the 6 operators in the assignment. What are they? Less than, equal to, greater than, equal to, and not equal to. So these are the 6 comparison operators about which I will be talking about today. Then I will be talking about 2 identity operators. Let me just clear the screen and just let me just again. So there were 6 comparison operators. These are the 6 comparison operators. And then there are 2 identity operators, which are is and is not. So these are the 2 identity operators. And then there are 2 membership operators, in and not in. So let me repeat. There are 6 comparison operators: less than, equal to, greater than equal to, and not equal to. 2 identity operators, is and is not, and 2 membership operators, in and not in. Then there are 3 logical operators: and, or, and not. And then there are 6 bitwise operators: and, pipe, tilde, and I don't know what is this called, this and this. So these are the types of operators about which I will be talking about today. So let's move further. Let's talk about the assignment operator. This we have already discussed. In Python, the E is assignment, and this I think we have already this. But let me show you an example again, just as a repetition. So if we have something like, say, x equal to 5, and we run this, and we print x, we will get a 5. Somebody's talking on the. Can everybody else please mute themselves? I can hear someone talking in the background, right? So if x is equal to 5, this is basically what is happening over here is that we are assigning x a value of 5. And when we ask the compiler or the interpreter to print the value of x, we get a 5. Now there are certain things over this. Now you cannot assign values to a non-variable. For example, you cannot write 5 is equal to 5. If I run this, I'll get an error. But what error? Just let us see the error also. What the error is saying, cannot assign to a literal. Now this 5, this 5 is a literal. It is not a variable, it's a literal. It has a value. It is this thing. So you cannot assign anything to a literal. You cannot assign a 5 to a 5. You can assign a literal to a variable, but you cannot assign anything to a literal. And for that, you need to understand the meaning of the word term literal. This number 5 is a literal, right? This number 5 is a literal, right? You cannot assign like that. So you can, now again, let me show you another example. You can assign a, that this is fine. This is fine. But you cannot use, let me just do it. Now if again I'll get an error. Why? Why I'm getting an error? Because this a is also a literal. It's a literal string. Whereas a without the quotation marks, a without quotation is a variable, but a with quotation marks, it becomes a string. So it's a literal. So you cannot assign 5 to a. I hope this is clear to you. But you can assign the 5 to a variable a. I hope this is clear to all of you, right? So let's go back to the presentation. So just one thing I would like to repeat again and again. You can think of the variable a as a box which contains the value 5. This is very important for those who come from a non-Python programming background. For example, if you're coming from C++ and from Java background, in C++, you can do something like int x, semicolon. So when you do this, the Java interpreter will create a box, and the address of this box will be x. And this box need not contain anything. But you cannot do this in Python. Let me show you. If I try to do something similar in Python, suppose I write int x equal to 5 and I run this, invalid syntax. So Python does not allow you to describe the type of the variable. Python does not allow you to describe the type of the variable. But had this been like Java language or C++ language and you had used a semicolon over here, this would have been a perfectly valid, perfectly legal statement in C++ or Java. In fact, you could have done like this also. So if you had done, let me show this thing. If you do like this in C++, what the C++ compiler will do is it will create a piece of memory called X, and it will have nothing inside that memory. So there's nothing, that is blank, it is null, it is zero, not zero, it is null. So this is the difference between Python and C++. Python and C++. This is why Python is called a weakly typed language, weakly typed, whereas C++ is called a strongly typed language. Because the type of the variable has to be told to the compiler in C++. C++ will not try to guess the type of the variable the data it contains by looking at the data. However, Python, you cannot tell the Python compiler the type of the data it contains. It is the Python compiler which will on its own determine the type of the data which it contains, right? So this makes Python very, very powerful and very, very dangerous, if I may use the word, at the same time. So you can write x equal to, if you write x equal to A, B, C, as I showed yesterday, and I write print type x, and I run this, I get class string. Now suppose, now you see, you can't do this in C++. And now I can change it. I can write now x is equal to 5, and I can just so I'm getting class for x. So over here, let me just show this. So in this line, x is a string. In this line, x becomes an integer. You can't do this in C++. Once you make x an integer, it will continue to be an integer. You cannot do this in C++. You cannot change the type of the variable once you have created in generally you cannot do it in C++ and Java, but you can easily do it in Python. That's why I say that in C++, the memory is a box which contains something. It's a box which contains something. But in Python, the memory is suppose there's a quote here. Let me draw a quote, something like this. Suppose there's a quote here. In Python, this thing is like a price tag x. So you can remove this price tag from the quote and put it maybe on a shoe. You can cut it from here and put it here. So the same variable can contain a data of one type or another type or a third type, no problem. So this is what is the difference between. That is why it is called weakly typed languages, and that is why people who are coming from background like so you will see something like void int x, something like that. You will see in languages like C++, but you will never see this kind of statements in Python. There are certain recent developments where they are saying that there's a new concept in Python called type hint. I'll not talk about that. That's a slightly advanced concept, but if we go to that level, we can talk about that also, about type hints. But you can do your own private research on what are type hints in Python. And most of the modern Python libraries nowadays are being written with type hints. That type hints basically means that the program is containing certain hints about what that data type could be, and therefore because if you do not have the types of the variables, then there are chances of making a mistake. For example, here suppose I do, if this was y, and then I write z equal to x plus y. Now, what I'm doing, I'm adding a string to a numeric. This will throw an error. Just let us do it. Error. See, can only concatenate string to string, not to integer. That is why the problem is this. But this kind of problems are very difficult to detect in a language like Python, but they're very easy to detect in a language like C++ and Java. Therefore, we always say that languages like, just one sec. Uma, Ashok, ये दरवाजा बंद कर दो, आवाज आ रही है पूरी. That is why in languages like we say that C++ and Java are what is called type safe languages, whereas Python is not that much type safe. That is why when you have to write very long libraries, very long programs, very long projects, you need to be very, very careful about the typing of the languages. In fact, they use a term called, let me use it, that they call duck typing. Duck typing. In fact, I've written an article on this. I will share the link of my article. It is available online on what is called duck typing. Duck typing, what does it mean? It means that as long as it talks like a duck, walks like a duck, it must be a duck. So what this basically means is that I don't care the kind of data your variable contains. I'm not interested. All I'm interested is the way it behaves. If it is quacking like a duck, if it is walking like a duck, it must be a duck. This concept may not be very clear to you right now, but I'll try to explain this concept. I've written an article on this. I will share the link with you all guys. So let us move ahead. So, okay. Let us go to the next slide. Reassignment. Let's talk about this reassignment. Okay. In Python, you can, you can do in any programming language, you can do A is equal to A plus 5. Now, in normal mathematics, if you do A is equal to A plus 5, this is not permitted. But here, what is happening? It is a two-step process. The first step, A may 5 is being added to A, and then that the value then is being assigned to A. Let us do it on our this thing, right? So let us do it here. Let us do it with that is right. Let me write down. Let us write x equal to x plus. Now first we have to assign something. Let us say x is equal to 10, and then x equal to x plus 5. So we should get a value of 15. Let us do it. So we're getting 15. I hope it's let everybody see this. So in the first line, we have done x equal to 10. So we have what we have done. X has been assigned a value of 10. Now in the next line of code, what we have done, we have taken on the right hand side, we have x plus 5. So what has happened? To the 10, a 5 has been added, and the result, which is 15, has now been assigned to x. So why is it called reassignment? This is called reassignment because the earlier assignment to x was 10. But now after adding 5, this has been reassigned to x, and now it has become 15. That is why it's called reassignment. So I hope that is clear. So let us move ahead. Okay. Now reassignment, there is a shortcut to reassignment. We can do it. We can write this as so. Let us see this code again. This is a shortcut. So what has happened? In the first line, we have done x equal to 10. In the second line, we have written x plus equal to 5. So there should not be any space between the plus and the equal to sign, right? They are one. So this is basically equal to x plus 5. So this is a reassignment, right? So plus equal to together, if they come together, if you see in a piece of code something like plus followed by equal to, so x equal to something to 5, you should be able to mentally see this as x equal to x plus 5. So this is this. So plus equal to is a reassignment addition operator. Reassignment addition operator. This will, why I'm saying reassignment addition, because this works for other this thing also. It works for other operators also. I will just show you. Suppose I write minus. Let me run this. So now I'm getting. So now I've written x minus equal to 5. So now we have minus followed by a equal to sign. So this is a subtraction reassignment operator. So similarly, we have for multiplication and division. By the way, if I put a space, let me put a space between them. Let me run now. Error. So let me show you what is the error. Why? The error is there because I put a space between the, so I put this space equal to. So if I keep a space between the minus sign and the equal to sign, it will throw an error, not allowed. Hope that is clear. So now if I do 15. So what is happening? Here, this is called a multiplication reassignment operator. So this is a multiplication, which is a asterisk followed by an equal to sign. This is a multiplication reassignment operator. Okay, let me just stop here for a second and just understand. Am I audible? Am I clear? Am I visible? Is everything okay? Somebody would like to answer? Anyone?
Yes, sir.
Yes, sir. All good.
Yes, sir.
All good so far?
Yes, sir.
Yes, sir.
Excellent.
Yes, sir.
Okay, excellent. So I just got a little bit of feedback. So, okay. So I think the reassignment operators are clear. So, right. Let us move to the next one. So this I made a table. Let me just. So these are the reassignment operators. This is equal to this addition reassignment, subtraction reassignment, multiplication reassignment, division reassignment, modulo reassignment, quotient reassignment, and exponential reassignment. You can do the research on your own, but these are the 1, 2, 3, 4, 5, 6, 7, 8 types of reassignment operators, which you might see in your whenever. So it is equal, plus equal, minus equal, multiplication equal, division equal, then mod equal, then quotient equal, mod equal, quotient equal, and finally exponential equal. You can do your own research. It's not very important, but if you are going to be reading code of other persons, you should be able to read these things. So let's move ahead. Okay. Now we are coming to the mathematical operators. So we are finished with the assignment and reassignment operators. We are coming to the mathematical operator. Let me just. I don't know how to remove. Let me put it here. Okay. So this is very, very clear. Now the plus sign and the minus sign, they can be unary or binary. As I have explained, I think yesterday, if I write x equal to plus 20, then x is acting like a unary operator. It is saying, it is assigning 20 to this thing. I could have written x equal to minus 20. So plus and minus can be unary or binary. If they are binary, then suppose we write x equal to 5 plus 3. Then this plus sign is acting on 5 and 3. Multiplication is clear, division is clear, floor division. Floor division gives the integer to the left of the number line. This is very important. Floor division. So if you divide 7 by 3, this is written, if you divide 7 by 3, it will give you the integer to the left of the number line. That means it will give you 2 and not minus 3. So you can just modulo operators and exponential you can do on your own. I think I'll skip this, not very important. Order of precedence, I think we can skip it. Okay. Type of operands and the resulting, this is a bit important. Type of operands and the result of operation. When the two operands are of the same type and the result of operation is also the same type, Good example is adding two integers. So if you are adding 2 plus 3, you will get a 5. The type of the result 5 will also be an integer like 2 and 3. No problem, simple. When two operands of the same type but result operation is of different type. For example, division of an integer by another integer results in a float. But if you are dividing an integer by, let's divide 6 by 6 divided by 3. So the answer will not be 2, the answer will be 2.0. So even though the 6 and the 3 are both integers, whenever you do a division, the result will always be a float, even if the two, the dividend and the divisor, even if both of them are integers, the result will always be a float. This is important. You need to understand. Okay. Whenever an operation is done on operand, the programmer should be aware that different operations may give different results, types of the results. You as a programmer, you as a writer of code, should always keep in your mind that whenever you are doing any operation, the output comes, what is the type of the output, right? And this is called casting. So casting can be of two types, as I had explained that day. It can be explicit, or it can be implicit. So explicit typecasting happens when you as the code writer, when you as the programmer tell the compiler specifically to do the typecasting. I will give you examples. However, the casting is implicit when the compiler does it on its own. Let us understand this by some examples. So let me see. Let us write x equal to 1.5. Then I write y is equal to so sorry. So let us look at this. So we are doing an explicit typecasting here. Here x is assigned a value of 1.5. Now in Python, there is a function called int, which can convert whatever is inside data given into an integer if it can be converted. So what it has done, it has converted the 1.5 into a 1. All right. So this is an example of explicit typecasting. You as the programmer are writing a piece of code telling the compiler to convert the 1.5x into y1, which is your y, right? But as we said yesterday, we did this thing also. Suppose we write x equal to 3 and suppose write y is equal to 1, z is equal to x divided by y, print z. So we are dividing, let me show this. So x is an integer, y is an integer, and z is a division of two integers, 3 divided by 1. So the answer should be 3. Answer should be 3. No, but what the compiler has done, it has converted the 3 into a 3.0. It has converted the type of z from a integer to a float point number. So I hope this is clear. Let's move ahead. Okay. Now let us talk about, this is very important because comparison operators. There are 6 comparison operators. less than, which is given here, less than equal to, which is given here, greater than, which is given here, greater than equal to, which is given here, equal to, which is given here, and not equal to, which is given here. Let us read what I've written. Now, less than true if left operand is strictly less than the right operand. That means that if we have 4 less than 5, this will be true. But if we have 4 less than 4, this will be false. On the other hand, we'll take examples. For less than equal to, 4 less than 4 will be true here because it is 4 less than equal to. So similarly, all the 6 operands are there. I don't need to go into details. I will just show them by example. So let me just wait. I would like to show that. One sec, I'm just showing. Yeah, comparison operator. Let's do this now. I'm honestly. Let me just bring this here. Yeah. So let us take examples of a comparison operator. Now, you see, the first thing you need to understand about compare, let us do this. X equal to 5 greater than 3. So let us see this. What I've done here is I have compared 5 to 3. 5 greater than 3. This is called a Boolean context. Boolean context. Because the output that it will generate will be a bool. That means either it will be true or it will be false. This is very, very important because in all your program writing, whenever you have to compare values, you'll have to compare things, objects. So whenever you do that, you will require one of these comparison operators. So here, 5 greater than 3, this thing is coming out to be right. Now suppose I make it greater than equal to, let me use this. And let me do it 5 greater than 5. Let me run this false. Because 5 if 5 greater than 5 is not true. 5 greater than 5 is not true. Therefore, it is false. Therefore, this is coming. But if I use 5, now let me run, is coming true. So 5 greater than 5 will be false, but 5 greater than equal to 5 will be true. I hope this is clear to everybody. Is it clear? Somebody can just say yes. I will then keep on going.
Yes.
Yes, sir.
Okay, clear. Right. Let's move ahead. I think maybe we are going a bit slow. We need to speed up things. So other comparison operators are also like this. Now, the only one I'd like to mention again is about the equal to comparison. So let us do this. This should evaluate to true, right? And if I write, just see this. So don't get, so this is, just see the syntax. This equal to sign, this is assignment. And this double equal to sign, this is comparison. Very, very important. So what is happening here is that 5 is being compared to the other 5, and whatever is the output is being assigned to x. So when you write x equal to 5 equal to 5, this is what is happening. The 5 is being compared to this 5, and the result is being assigned to x. I hope this is clear. So on the other hand, if you write, let us run this. So it is giving false. So it is, this is means 5 is not equal to 5, which is not true, therefore it is false. Right? But suppose I make it 5 not equal to 6, and I run it, I'll get true. So if I write 5 not equal to, this is not equal to 6, I will get an output of true. Because 5 is not equal to 6. So I hope this is clear. Let's move ahead. So we are done with comparison. Then identity operators. You see, there is a very important concept here. The identity operator is and is not. Is and is not. Let me take this with an example. It's there in my, on the, you see, I've created some HTMLs which are available. Let me show this. These are available on this link. Let me copy this link. And how do I paste it in the message? Chat. So these are the, this I've pasted the link of this link I pasted, this link I pasted in the chat box. If you click on this link, you will get this page. And below this page, you will get material for the first 20 chapters of my book. And if you click on this third chapter, which we are doing right now, you will get this, right? This has a lot of data material on what I'm teaching right now. So, okay. And now we have done comparison. We are identity, is and is not. Let us do this. A equal this. We are on this line of code. This is on idle with a triple this thing. Forget about it because we are not doing it on idle. We are doing on Jupyter notebooks. A equal to B equal to 1, 2, 3. So basically what is happening, a list has been created. This is the list 1, 2, 3. It has been given to two variables, B and an A, right? And then another list C has been created, which is also 1, 2, and 3, right? Now, in Python, there's a concept called object ID. Every object has an ID. Every object in Python has an ID. And there is a function called ID. And you put the object inside that function. You put the object here. Let me clear this. Let me just. So in Python, every object has an ID. And ID followed by the name of the object inside will give you the ID of that object. Let us do this on our this thing. So let us write A is equal to B is equal to 1, 2, 3. All right. So let us do print ID of A. So this is what we are getting. So let me just show this. So what I did was I I created a list of three numbers, 1, 2, and 3, and I assigned it to two variables A and B. And I am checking out the ID of A. इसका मैंने ID check किया by using print ID A, and I get this number, right? So, okay, now let us see print ID of B. So you can see that both A and B have the same ID. So what does this mean? That means A and B both point to the same object in memory. That same object in memory, which is a list 1, 2, and 3. So A and B point to the same object in memory, right? So now let me just show you something else. Now I say print A is B. So what I'm saying that whether object A and object B are same, let me run, I get a true. As you can see, when I write print A is B, I get a true. Why? Because A and B are both pointing to the same object list 1, 2, and 3. But let me do a variation over here. Suppose now I write C. So what I've done, I've created another list C containing the same three members 1, 2, and 3. Now let me see what is the ID of C. Print. Let me see C. I'm writing so that there's no confusion. ID of C. Let me run this. So I'm getting a different number. I'm getting, let me show this. So let me show you the A and the B. The ID A and ID B are this number, both are same. But ID of C is different. That means, what does it mean? That means there are two lists in the memory. There are two lists in the memory. One list is being pointed to by C. The other list is being pointed to by both A and B. A and B. So even though the members of the list are exactly same, they are two different objects in the memory. That is why the IDs of the two objects are different. So now if I write print A is C. So basically I'm trying to find out by this statement. Let me just create some space over and let me write something here so that let me run this. False. Now let me just show you. So I'm comparing A to C. This first part of the print statement is simply a string which will be typed as it is. The second part of the statement generates this. So this I put this here, so it comes here so that we know. So A is C, it is false. That means A and C are not pointing to the same object. So comparison operator is not about whether the two objects are equal, but it is about whether the two objects are same. Now let me do something little different. Let me write print A equal to C. What do I get? I get it. Let me write here. So what I'm doing, R, let me just show this. I'm comparing A and C, I'm equating. So I'm not trying, when I write A equal to C, or when I'm writing A is C, these are two different operations. When I am writing A equal to C, I'm basically comparing the data contained inside A and inside C. So which is giving us a value of true. But when I'm saying A is C, I'm seeing whether they are the same object is giving a value of false. Therefore, equality, comparison and being the same object are two different operations in Python. This double equal to sign compares the values of the two variables, but the is operator sees whether the two variables point to the same object or not. Is this clear? Let me stop here for a second and just take a feedback. Am I okay so far? Somebody would like to answer? Anyone?
Yes, sir.
Yeah,
Yes,
okay.
sir. Clear.
Okay, so let's move ahead. And same is not. Is not also you can. The thing is not. Is not is just the opposite of is, and you can I can just show you is not also. So when I write A is, if I write A is not C, then I get A is not C, compare and see. See, just let me show you. A is, so I'm using A, C, and in between I'm using the operator is not. Don't forget, this looks like normal English language, but this is an operator. And the format has to be like this. Is space, not space, the second operand on this side, the first operand on this side. So it can be X space is not space Y. That is how it is. So it is not is an operator. Don't think it is some language. It is it's some it's an operator, right? So I think we have understood that. Let's move ahead. Okay. The other is in and not in. These are called membership operators. In and not in. Evaluates to true if it finds the variable on the LHS in the specified sequence on the RHS and false otherwise. Evaluates to true if it does not find the variable on the LHS in the specified sequence on the RHS and false otherwise. It's very simple and easy. Let me just show this to you. This thing also. Just one sec. Membership, yeah. For example, if string A is in string ABCD, this will evaluate to true, right? Similarly, if 5 letters is in list, five in a list containing say 1, 2, and 5, it will evaluate to true, otherwise it will evaluate to false. So I think membership operator also you can do on your own little bit, and we can move ahead. Then comes logical operators. These are very important. There are 3 logical operators, in fact, and, or, and not. So all those who have studied high school mathematics would be aware that basically and evaluates to true if both the operands are true, or operates to true if either or both of the operands are true, and not is a, no, by the way, and or, and or, they are binary operators, but not. This is a unary operator. That means it operates on a single operand. So let us take some examples of logical operators. I think I didn't put it. I'll give an example of a few logical operators. Let me just open my book. Yeah. This is from my book. Think of an AND operation in a situation where two criteria must be satisfied the result to be positive. For instance, please give an example. Some students are studying English and science and required to pass in both in order to be promoted. So this is English, this is science, and this is promotion. So if somebody fails in English, fails in science, fails. Fails in English, passes in science, fails. Passes in English, fails in science, fails. Passes in both, he passes. This is an AND operator. Simple. I think everybody knows this, right? On the other hand, suppose you have to, either only you have to pass in only one. Then if passes in either one, then it passes. So I think it should be quite clear. Okay, so let us come back. Let us give a few examples. Let me just one sec. Let me give an example. Let us do this. Let us take this. Let us write this. Y is equal to 6 greater than 5. And Z is equal to 7 greater than, say, 6. And I write A is equal to Y and Z. Print A. So I'll just show you. So Y has a value of true because 6 is greater than 5. Z also has a value of true because 7 is bigger than 6. So if you have Y and Z, that is basically you're writing true and true. That means if both are true, then the result will also be true. But if one of them is false or both of them are false, then the result will be false. Let us do it. Let us make this Z false. Let us put a 5 over here. Let us run it now. So you can see. So here Y is true but Z is false because 5 is not bigger than 6. Therefore, A, which is true and false, will evaluate to false. I hope this is clear to all. And if we put this also to be false, let us put 4 here. In fact, let us see what is y equal to. Let us write print y. So y is false here. Let us do this. So y is false. You can see y is false because 4 is not less than greater than 5, and z is also false. Therefore A is also false. I hope this is clear. So this is what the logical operators are, and, or, and not. Now let me just show about not also, because many times people may not know not. So let us write x equal to true. Print x. So we get true. Now let us write y is equal to not x. Print y. We get a false. Let me just show this. So in the first case, x true. So we have assigned to x a bool value of true. And then to y, we have assigned a value which is the not of x. Since x is true, the not of x becomes a false. Therefore, y turns into a false. All right, don't get too worried if you are not able to see how these are being used. The moment we start moving into functions and classes, you will immediately need these concepts, and these are the very, very basic concepts. Might be a bit boring also, but these are important, so we have to go through them, right? Let's move ahead. So we have done this. Okay. Next is bitwise operator. I'll skip bitwise operators for the present. Bitwise operator I'll skip because it's a bit it requires a little bit of binary mathematics and all that, which is not really required for your course. So let me stop here for a minute and I can move on to the next topic, chapter 4, that is on functions. So let me stop for a second and let me take some feedback from people, because we have been going for about 45 minutes, 50 minutes. So let me understand, is everything clear so far? Somebody would like
Yes,
to
sir.
answer?
Yes, sir.
Any confusion? Are we good to move ahead? Because we have about 1 hour more and I would like to cover chapter 4 also today.
Yes.
Yes, sir.
Okay, fine. So let us go to chapter 4. This is in fact, now we are coming to the actual programming part. So this is chapter 4 of my book, and let us come straight to the learning objectives. So we will be dealing with the concept of functions. And if you want to be a programmer, if you want to be a hacker, if you want to be a data scientist, whatever you want to be, functions are the bread and butter of your programming. You need to understand. Very, very important. I like to divide functions into 3 types: built-in functions, functions imported from modules, and functions written by the programmers. So let me just repeat them. Built-in, imported, and written. You see, you as a programmer, 90% of the time you will be using either the built-in functions or the imported functions. That means whenever you are using any Python libraries or this thing, then you are using functions which are written by others. You are not writing the function. But at times you may have to write the function yourself, then you have to write it. So when you are using a function, so let us see difference between writing and calling of a function. Let me just expand this. Difference between writing a function and calling a function. This is very, very important. Most youngsters who start programming for the first time, they don't realize the difference between writing a function and calling a function. But they are two different things. I'll talk about it. Okay. So I said there are three types: built-in functions, functions imported from modules, and functions written by the programmer. Built-in functions are uh, there from modules, maths, and random. Okay. Then, okay, let's move ahead. Let us, what are Python functions? This is theoretical. A function is a named sequence of statements. The term I'm using is a named sequence of statements. It contains some lines of code which are executed sequentially, that is one after the other from top to the bottom. It can perform computations. This definition can be explained as follows. Suppose you have a block of code which you want to execute. You can name it by function name and use or reuse it in a script. Right? Hence, if a function is a technique whereby you can form a group or block of statements and give them a function name. Function can do the following two things. They can take parameters and they can return values. So let us, without wasting much time, let us move ahead. Let us come straight to built-in functions. Now, for example, let me do this absolute x. Now, suppose you have x equal to minus 9 and y is equal to abs x. So let me just show you. Now what I have done, this absolute abs is a built-in function of the Python library. That means it is the core function of the Python library. You don't need to import it from anywhere. You don't need to call it from anywhere. You simply use it and you will get the thing. So what it does is it creates the absolute value of -9, which is a negative number, and it converts into a +9. That is how we get this. So this is how we use. So built-in functions will not have to be imported from anywhere. All right. So let us move to the next type. Okay. In my book, there's another example of absolute of a complex number. Let us do that also. Right. Let us write is equal to 3 plus 4j. So for those, let me just run it first. We get 5.0. So let me just, for those of you who are mathematically inclined, might be interested. So you have two planes, the real plane and the complex plane. So when you write 3 plus 4j, it is 1, 2, 3 here, 1, 2, 3, 4 here. So this number is basically this number. The absolute value is the hypotenuse of this triangle, which is 3 square plus 4 square under root, which gives to 5.0. So if you don't understand this, also it is fine. If you don't have a mathematical background, also it is fine. But the point I'm making is that absolute function works not only on integers and floats, but it also works on complex numbers. This is a complex number. Are we good so far? Somebody would like to respond? Are we good so far? Anyone? Anyone?
Yes, sir.
Are we okay? Things are going fine? Okay,
Yes,
fine.
sir.
Yes, sir.
Yes.
Yes, sir. You can go on. You can carry on, please.
Right. So let us move to the next topic. So built-in function I've explained. Similarly, bool. There's a function called bool. This is a very interesting concept. A bool will generate either a true or a false, right? So let me just show this. X equal to bool 1. Print X. Oh, sorry. I wrote a 0, that's why I got this error. So what is happening? So this is an example. Let me just expand it for you. So what I'm doing, X is being assigned a value of bool of a number 1. So what this function is doing, it is taking an input of 1, the parameter is 1, and it's converting into a bool value of what? Of true. Right? So in Python, positive integers will always evaluate to a bool of true. Let us see whether it is 0, then what happens? We get a false. As you can see, when I write bool of 0, I get a false. Let me see bool of a negative number. I get a true. See, very interesting. So bool of a negative number will evaluate to true. Bool of a 0 only will evaluate to false. This is the way Python has been written. Now somebody might argue this is not logical, this is not right, this is not correct. Bool of negative number should be 0, but bool of a negative number in Python is a false, is a true, not a false, right? Similarly, if I write bool of 0 plus 0j, let us see what happens. It gives a false. So bool of a complex number, this is a complex number, minus 0 plus 0j. But the bool will be a false only if the real part, which is a 0, and the imaginary part, which is also 0, if both are 0 only, then it will give a false. If I was to write bool of, say, 1 plus this thing, I'll get it true. You can see. If the imaginary number has a real part is not 0, imaginary part is 0, then it will give a true. So this is another function which is a built-in function of Python, right? So what evaluates to true and what evaluates to false is given in this slide. You can read it. 0 may be 0, 0.0, or this thing, none. Bool of none, if you write bool and within bracket you write none, you will get a false. Bool of an empty sequence. So therefore, if you write bool, let me show it, within bracket, an empty list. Let me show this, both of these, because it's important. Bool of none, I get a false. You can see. Bool of none gives false. Okay. Similarly, if I was to use an empty sequence, any sequence, if I use this, by the way, This is an empty sequence of string. Let us see this. Gives a false. So here, this single quote, without anything in between. This is an empty string, empty string. But suppose I was to put a space in between. Let me put a space. Now let us see. True. So if the string is empty, this is not an quote, single quote, space, single quote. This is not an empty string, but single quote is an empty string. That is why this string, which is not an empty string, gives you a value of true. Right? Now let me put a list here. If I put a list, also I'll get false. But if I put something in it, if I put a 0 in it, I'll get it true. So the list should be empty. If the list contains even a 0, if the sequence contains anything, including a 0, then it will be evaluating to true. Right? I think that is clear. Let us not waste too much time on this. Let us move ahead. This I'll skip. Char X and order X, this thing. For ASCII codes and Unicodes are there, but I don't want to go over this because it will compare, it will unnecessarily waste time. Comparison also I will skip. Div mode I will skip. Float. I think you can do ID. I've already explained to you. Int I've explained. Len. This is important. Let me go this. So basically, this PowerPoint, which is there on my GitHub page, you can download it. It is showing you the various. We are talking about built-in functions. So let me just recap. I said there are three types of functions: built-in functions, imported functions, and functions written by the programmer. Right now, we are talking about the built-in functions. We spoke about absolute function. We spoke about the bool function, and now we are talking about the len function. The len function returns the length of the given object. The argument x must either be a sequence, such as a string, or a collection. So I'm saying again, it should either be a sequence, means a string, range, list, or tuple. We have covered strings, we have covered lists, we have covered tuples, we have not covered range. We'll talk about that later on. Or it can be a collection, such as a set or a dictionary. If the argument s is a string, that means if this thing is a string, if this is a string, then let return the length of the string s. If the argument is either a sequence or a container, then give the number of items in the sequence. Let us see this. Let us just try it out. Let us write. Let us say x equal to ASDF. Print. So what I did was I created a string ASDF, which had 4 characters in it. And when I asked them to find the length of x, I got a value of 4. So for the string, it gives you the number of characters in the string. Now, mind you, even empty space is a so suppose I put a like this. Now let me run. So I'm getting 5. So this AS space DF, it is containing not 4 but 5 characters. So the length of this string is not 4, it is 5. I hope that is clear. Now let us take some other example. Let us take another sequence like a list. Let us take 1, 2, 3, 4. Now let us run this. We get this. So there are 4 items in this list has 4 items: 1, 2, 3, 4. The number of items is 4. So it is the thing. By the way, just as a recap, if I was to print x 0, we cannot do it. It will not find this thing. but we can do x0. I'll get 1. That is this is the item at index 0. So the item at this 1 is at index 0, just as a recap. All right. So let us go further. Range. This is a very, very important function. Let me just range function, it generates something. So what does it generate? I'll tell you. There are 3 possibilities: range stop, range start stop, and range start stop step. So let us run it. Let us first use range start. Zero to 5. One second. It's a little bit of confusion here. Let me open chapter 4. Wait, just one sec. Just give me a second. I'll just confirm about range function. Okay, I'll skip over this range for the minute. I will come back to this later on. Just bear with me. I'm a bit this thing about range. So we'll come to range later on. Let us move ahead. Let me just it is used in loops, but let us not waste our time on this right now. Let us go ahead. Round. Okay. So I think we can skip all this. String is a also important function. So we can skip all this. Let's come to the what is called the functions which are built in module. That means I said there are built-in functions, imported functions, and functions written by the programmer. So let us come to a module called math in Python. Right. So let us do this. Let us do this. So whenever you see for the functions which are built into Python, you did not have to import anything. But for the functions which are in the modules, you have to import the modules. So let us do it. Import. Okay. Now let me just understand that, write this code for you. You will just take a little bit of time. The first thing is we have imported a module called math. We have imported a module called math. This is import is the most important, I may say, statement in Python, because whenever you are using any of the libraries, you have to first import it. Now you need to understand. Now this math library may contain a number of functions and classes inside it. There may be, so if you want to go, you can go look at the source code also, but we'll not go there. One of that function is CEIL, which stands for ceiling. CEILING, ceiling. So if you have 7.23, it will generate the integer which is the highest non-decimal number. So from 7.23, it will give you an 8, right? So, but just you need to see how it is used. Math.ceil, and then you have to give the data, right? So you have to, if you don't write math, suppose I don't write math here, I write ceil. Suppose what is happening? Suppose I write, let me run this now. I get an error. Let's see. So what is happening? The Python interpreter is saying ceil is not defined. That means the Python interpreter is unable to find out ceil kahan se aaya, from where CEIL has come. So you have to give the path to the CEIL, which is used by what is called the dot notation. You write math dot ceil dot x, and now you run it. You will get a perfect answer. So the way to do is this: math.ceil x. So once you write a statement like import math, so now all the functions inside this module can be used using the dot notation, math.ceil, or whatever else is there, right? Now let me just show you. Similarly, there is math. I use this math.ceil. There is math.fabs, which gives the absolute value. Math.floor, which gives the floor value. Math.exponential, the e to the power x. Math.log10. Math.power x comma y. So now you math.power x comma y takes two arguments, where x is the base and y is the power. I will use this. So there are many other such functions. So let me use math.power x dot y, x comma y. So let us write x equal to 2, y equal to 3, and z equal to math dot POW 2, 3. And let us print z. So we get 8.0. So this is this. So let me just show this. So this function POW is taking two parameters, the first parameter and the second parameter. The first parameter is the base, and the second parameter is the exponent. So basically, it is calculating 2 to the power 3, which gives you an 8, but doesn't give you an 8, it gives you 8.0. That is why you get an 8.0. So this is a function which takes two inputs, 2 and 3 here. But suppose we were to do 3, 2. You should get a 9, 3, 2. Let us see. Because now the base, now it has become, it is done. So you can see it is 3, 2. So the base now is 3 to the power of 2, which will give you a 9. So I hope this is clear, right? Now, this is a very interesting. Suppose we could have written this statement in a different way. From math, import POW. Let us run this now. We get it. So, but just understand. This is a very important concept which all of you should understand. from math import POW. Earlier I had written import math. So all the entire math module had been imported, and I can use all the functions available in the math module. But now I have written from math import POW. So in this statement, only one function POW has been imported. So if I try to use any other function like seal in this case without importing it, then it will throw an error. I'll just show you. Let me run this. Oh, this is running. This is running because in Jupyter notebooks, once you import, it remains in the memory. But if you were using it on, and let me restart the compiler. Let me restart the kernel. Let me restart the kernel. Okay. See. Now it is see from math import POW. Just see this. The error is important. I wrote from math import POW. So the Python program only understands POW. It does not understand math because math has not been imported. Only POW has been imported. Right? Right? So therefore this error is there. But if I was to write import CEIL, then I have to remove this math. Now let me run this. Let me run this now. Getting me correct answer. So now the Python interpreter understands CEIL because it has been imported from the module math. However, if I try to use math.ceil here, if I run this, it will again throw an error. Why? Because the Python interpreter does not understand math.ceil. It only understands CEIL. So this is very important. If you are using from the module, if you're importing something, then you don't need to write math.ceil. But if you're importing the entire module math and you're using a function inside that module, then you have to use math.ceil. So I hope this is clear. I think this is an important concept. I think I should stop for a second here and just take feedback from you guys that you are able to understand this so far, then we can move ahead. Somebody would like to tell me that import, simple import and from module import, the difference?
Sir, can you please repeat if we are importing from Mac imports CEIA, what would be writing Z?
It should be simply, it should be like this. So now we cannot use, we can use Z is equal to CEIL of 3.9, but we cannot use Z equal to math.ceil 3.9. Because this math, the interpreter does not understand this because it has not been imported. Something has been imported from math, but math has not been imported. The math module has not been imported. The CEIL function from the module math has been imported. That is why you have to use CEIL 3.9. And in fact, only CEIL has been imported. So if you try to use something, say apps 3.9, it will again throw. This is creating and this is showing, not throwing an error because I've imported the function earlier. But if I do a, so I hope you have understood what I'm saying. Have you understood?
Yes, sir. Yes, sir.
Yes, sir.
So simple import and from this thing are, these are two different ways of importing in Python. You have to be very, this is a very important concept because even if you don't understand anything much about Python, you really must understand how the import works. Because if you don't understand how import works, then Many times you will have errors which you will not be able to understand why the errors are coming. But you need to this thing. In fact, you can. There's another sentence. Let me show that. Then let me show. This is import math as M. This is another way. Now let me run it. It'll throw an error. It is not throwing an error because let me just at least restart the kernel. Yeah, let me run this now. Surprising, I don't know, maybe some this thing, but if you do it, then you have to basically use m dot apps. अच्छा apps नहीं है इसमें CL होना चाहिए, इसमें होना चाहिए ना CEIL. So now what is happening? I'll just show you. Now we have created an alias for the module Mac as M. In fact, most of your high-end libraries, for example, matplotlib, so it will be as generally we import them as PLT. Similarly, if you're using pandas, you use PD. So you will generally see import pandas as PD. Suppose this statement is there and you want to use this library. Now you will be using PD dot something. You will not be using pandas dot something because now Python will not understand pandas, it will understand PD. So I hope this is clear. Let me stop here for a second because import is an important concept. So if everybody is understood, we can move ahead.
Sure, sir.
Yeah, okay.
Yes, sir.
So I've explained to you. Now let me just recap. We started with what is called the built-in functions, and then we are using the functions which are existing in the modules, right? So in both these cases, we are simply using the functions. We are not writing the functions. We are simply using what others have written for us, and that is what we are doing, right? Similarly, there's a function called random. So this is an important function, but I don't have time for this now. You can skip it. Choice, uniform, range. This I think. Okay, let me talk about this. Some important points regarding the return statement in a Python function or a method. So whether you are writing the function yourself or you're using the function written by somebody else, they generally have a return statement. It terminates the function call. The return function statement is used to exit a function and go back to the place from where it was called, right? It also returns the result, if any. The value returned by the return statement is the value of the expression following the return statement. This will become clear once we let us not waste time on this. Let us go. Okay. Now let me come to what is called the user-defined function. So this is not very clear slide, but let me just. So if you have to write your own function, you have to use the keyword def. So the moment the compiler sees this keyword def, it understands that the programmer is trying to write his own function. Def is followed by a function name. Function name, and there is a way of writing functions and class names in Python. I will explain that later. Followed by brackets, and in the bracket there are parameters, and then followed by a colon. So let me repeat. You have to use def, then space, function name, then no space, brackets containing parameters, and a colon. So when the moment the compiler sees this entire line of code in your script, it understands that you as a programmer are trying to write the function. And the rest of the function will follow this here, but with 4 lines of white space. This because this is called space indentation. Space indentation in languages like C++ and Java, the indentation or this thing is done by semicolons, but in Python it is done by white space. That is what makes it so readable, right? Now let me just again. So then there can be something called a docstring. Forget about the docstring. This is optional. Forget about it. Then there are statements, and there's an optional return something or nothing. So let me repeat. First is a keyword def, followed by the function. Let me just write it again. So I'm talking, there are 6 things in this entire writing of function. The first is the keyword def. The second is the function name. The third is the optional list of parameters. When I write optional list, that means these brackets can contain something, they can be empty also, but the round brackets must be there. They may have something, they may not have something, followed by a colon. So this is over. Then a docstring. This is also optional. We'll not worry about docstring right now. And then the statements in the function, and finally a return, which is also optional. If you don't write any return, the function will terminate on its own. It will not return anything. So this is how a function written. But this will be understood once we go over this. Something is wrong in my. Okay, anyway, let me give you an example of a function, then we can maybe just one second. Let me write a small function for you, and then let me just open my book also at page number 75. Just give me a second. I'm just yeah, defining your function and function syntax. Let me just so as I explained earlier, whenever you're writing the syntax of a function, you use the thing def. Yeah, def followed by function name, and then argument 1 to n. Then statements and return some object, right? Okay, def, the keyword def, this indicates the start of the function header. This is the function header. In computer programming, this is called function header. Function header. Why it is important? Because if you are writing your own function, or whether you are using somebody else's function, you need to know the name of the function. You also need to know the arguments it will take. And you also need to know the types of arguments, whether it can take an integer, whether it can take a bool, whether it can take an object, whether it can take a float, whatever. So this is the function header, right? So let us move ahead. Let's forget this. Okay. Now this simple function I've written, let us write it on a, let me write this. So right. Let me just one sec. Function, right? So I have defined a function. Let me write. Let me write this. So let me just run this. So it is not giving any output. Let me just go over this. This is a bit important. So I have done this. I have used the keyword def. I have named my function f1, func1. I've given it one parameter x. Inside the function body, this is my statement number 1. This is my statement number 2. And this is my return value. So let me repeat. I've used the keyword def. I've named the function func1. I passed it a parameter x. Inside the function, this now from here to here, this is the body of the function. This is the body of the function. Inside the function, there are 3 statements. The first statement I've converted, I've taken the x, given it to z. Then I've given a print statement and I've given a return of 0. Now, when I run this, nothing will happen, right? Nothing is happening. But suppose I say func 1, just one sec. Func 1, and I give it a value of say 5. Let me run this now. So now just need to understand this. This is the function definition, and this is the function call. Here I am calling my function by giving it a parameter of 5, by giving it a value of 5. So what happens? Inside the function, this 5 goes to z, and when I ask them to print z, I get a value of 5, right? And I return 0. Now let me just kill this also. Now let me write w is equal to func1. Let me print w. So what I get? Just see this. Hello. Huh? Just one second. हाँ भेज दो, भेज दो. So now what is happening here is that this return of 0 is returned by this function is going into w. So that is why we are getting a 0 over here. Now suppose I, instead of return 0, I write return say 5. When I run this, I will get a 5. So what is happening is that the 5 which is here, after the function goes, it will go into w, and this w will be printed as equal to 5, right? So is that clear so far? I think maybe we are going a bit too fast. Should we stop here? Let me take a vote from the class, because I don't know. Hello? Yeah? Everyone? Anyone? Hello? Any of the participants, would they like to speak, say something, whether they are able to understand, not understand?
Sir, if you remove the return statement, then what is the output?
If you remove, yeah, okay, let us do it.
And let's see what happens.
Yeah, let us do it. It gets a none.
Okay.
So if you have no return statement, then the W will return a none. Okay.
Sir, what is the purpose of return statement?
Yeah, okay. Suppose I want, let me give an example. Suppose, let me write this X comma Y. Okay. Now I write FUNC1 3, 4. Can someone tell me what I like it?
Yes, it will return 7, sir.
Right. So we have created a function which adds two numbers. So we could have called this, to make it more easy to read, we could have called it add one. So we have written a function which adds number. So the return value becomes important because we are using the return value to get the output, right? This is what it works. So this way we can we could have used 3 variables.
If you just said return, then no,
Right,
that
so-
then
Sorry.
if you just said return, nothing, no subsequent.
Okay, let us do
parameters.
it. Let us do it. I think it will not accept. Throw an error. None. It return none. Python functions always returns none. If they don't return anything, they'll always return something. So if you don't have an explicit return, it return a none. All right. So if you get a return of none, what does it show? It tells you that the function at least has executed properly. Right. Okay, I think we'll stop over here. I think it's more than 2 hours almost. So would somebody like to say anything, or should we stop here? Anyone? Somebody's written a comment.
Let's break here because you have a 1 o'clock
Yeah,
move out,
yeah,
so you can continue, no problem. I'll
I
continue for 10 minutes.
We have already covered chapter 3. Maybe I went
And
a bit
chapter
fast.
4 is already on the pathway. Yeah,
Chapter 4, yeah, chapter 4. There are of course many nuances to functions which I have not
Correct.
covered. So that we will do next time. All
Yeah.
right.
perfect. All the best.
So,
Thank you, sir.
Okay.
Okay, so team, there are some couple of tasks. Thanks for joining in. I know it's a holiday and you people could make it, so I'm so happy about it. I have a small request that we have chapter 1 and chapter 2 exams. Chapter 1 retest has been done, so please go for retest, because what happened, unless we find you on the same space where it is required for Osint scripting, it will not be worth chasing that actually. And we need to, as a team, we need to go there. So we'll request all of you to make sure that all of you are rewriting the exams. And chapter 2, if you want to revisit the video and then write, please do it, but it must be finished by 11 o'clock tonight. Okay. First exams, we have sent you the results, so you have answer. Please don't read the answer and write the exam, because it is your skill test. Without your skill test, no. One second. Yeah. And there is chapter 2 exams, also on now. So please attempt after visiting the video. Video is available on YouTube. Yeah, I'm sure that all of you have subscribed there. So I'm so happy for that. Please, revisit the video if there is a need for it, because up to, error handling, you need to be thorough about it. Without that, moving to next layer will be like, you learn the, theoretical nuances around that, but you will not enjoy the practical attached to it. Okay. And without that, there is no learning for Osint. Osint, I'm not teaching you people so that you become a Osint professionals, who buy Osint from outside. Okay. We want you to generate your own Osint if there is a need for it. And at the end of it, as a security professional, you should be able to generate some Osint on your own. That will be the success, criteria for this course. Okay. So expect all of you to be, finish the chapter 1 to exam. If there is a need for revisiting the video, please revisit it, we can't show you the result, just after the exams, let suspense be there, Ankur. So we'll declare as a part of it. There is a process attached to that and we'll follow that process. Okay. Any question for any one of you? Okay, no question. Then enjoy Lal Bahadur Shastri's birthday today.